Here is a new one. The reason why we're starting from the back is there isn't really a lot to say about the front. Test it. Oh, we can't see the date. Oh, damn it. Here, there's a date. 96. So it was tested originally Oxford Instruments 96. Oh, how cool is that? So now we finally know the age of stuff. So there's a sensor. And this is a temperature controller. VTC4. So there's like some external connectivity, remote auxiliary, and the sensor. There's a quite large heat sink. And caution about the mains voltage. Pretty cool. We can change the main voltage. 2 fuses. They even put a fuse in both of the line and 0. How cute is that? Let's look at the front. I normally don't like the way to do 19-inch rack mounts this way, because it's insanely fragile. Of course this unit was dropped or something, but all corners look like, yeah, this is really, really fragile. Quite sexy on-off button, and then a display. Some red, I don't know. Maybe we should we try and boot this up before we open it? Alright, let's try and power this up. Ooh, light. And it said, okay. Click, I can hear some relays and some blinky status. It's counting up. Ooh, scary. What is happening here? Maybe let me try and touch the sensor connector. No, it's not that sensitive. Maybe there's a capacitor that is slowly charging. I think we need to open this and see what happens. Let's try and turn it off and turn it on again because it's pass. Okay, yeah, that is what it said. Okay, it continues. Oh, and the status was actually blinking red. Let's try again. Pass, and then okay, no, it's just go green. It keeps counting. All right, let's try and open this and see what is inside. This looks easy. If you ever see one of those cases, here is the trick, because this took me a little while to figure out. The top plate is loose, so it can move left and right, and there are holes inside the aluminium here, so that the top is actually locked all the way when it is in the sensor position. So the trick is to move it all the way to the left or to the right. And there was a mark here, so somebody took a screwdriver and then they did something like this to get access. And what have we got here? A big flat cable all over the place. Ooh, what do I see? The good old Z80 from 95. How cool is that? So this is the RS232. I should maybe be careful about where I stick my fingers because it's still in mains. There's a little capacitor. Mains filtering, and oh yes, the input is of course also a mains filter. How nice is that? And a big, heavy transformator. Look at that. Really, really nice quality with a connector on it. Okay, look down here. Bridges and regulators and stuff. Definitely worth looking at. 8 megahertz oscillator. And really, really beautiful PCB layout. Look at that, and a relay for something is here on the heatsink. Okay, that's a big transistor. So all this is maybe just a power supply. So what is this? This is the timer circuit, right? More RAM, flash, EEPROM, and more RAM. No, this is the OKI. Ah, this is the clock. They made it really, really nice. And then there's another additional PCB doing, this is the sensor input. Wait, what do I see here? There is a temperature sensor here in the back. So this is for ambient temperature, for compensation of the ambient temperature. And what have we got here? I don't know what kind of sensor this is yet. Maybe I should look this up. Okay, so this is the on-off switch. This is where we do not touch. That many wires to do on-off. Okay, it's because it's also the LED or something to turn it on, or the light. And then all this for the sensors going here. So the sensors, where's the 80 converter? How is this converted? Oh, maybe no, it's not. I need to find the 80 converter. Maybe that is, because when I look at the, see, balanced lines, 2 of them done really neatly with some test points and some guard shielding. This is really done nice into the flat cable. So I suspect there will be an 80 converter somewhere. I didn't find it yet. It's just line driving. Alright, I need to go and look up a few things, and then I will come with some clever comments, I guess. RS on the connectors. So it's locked at 209.9. What have we got? The display. All this is just LED displays and some LED line drivers or some decoding. This is probably, yes, it is. See, multiplexed. And what is that? That is looking really weird. Oi. That flat cable is connected in a really weird way. So this is the display, yeah. This is the display board, and that cable that goes to the display board also go here. So this is just a remote display. In that same funny format that drives this display directly. Parallel flat cabling. Let's, oh, I definitely need to pull the mains plug. Let's have a look at this fantastic. What the heck is that? This is a cable splitter thingy. Have you seen this before? I have never seen a product like this before. And here is the number. Look it up from RS and then you can split cables. Ha! That is the coolest. So I just took away the 4 screws here in the front. And of course they did this right. Milled in the acrylic. Really, really beautiful. So this is the direct multiplexed signal, ULN 2803, Darlington drivers, resistors, and the multiplexing, the common multiplexing. Isn't that just cute? It's really, really beautiful made. Clearly high quality. And the display is mounted with those 4 screws into the same pieces of plastic that mounts the main board, and a few extras here. Note this little detail, a tiny little screw, so those are not freely moving, because this is normally annoying when they're just loose in here when you assemble the sides or something like that. But I've never seen those tiny little screws to lock them, because they're just, people don't really pay attention to this kind of detail. Normally they're just loose in there, and normally it isn't really a problem, is it? But yeah, maybe it's not that big a problem, but now this is where you've seen it first. I don't know if this is a game of Tetris or something, because you need to do the different pieces in the right order. So those 2 screws in here, they loosen up these, so you can change this to another type. Look, this is again made very, very well. And now you get access. Yes, I've seen that. So now they are out, and we'll get access to those screws because they're hidden in here. So this is how it's assembled. I am getting more and more in. It's really good quality. All the aluminium pieces. Look at that. Humongous. Huge. Oh. They made this really, really nice. A holder for a capacitor. Look at this twisted wires and the local capacitor on the regulator here. This is just so cute. So this is one of the power supplies that goes, and then there's a capacitor, and then it goes in this cable. Oh, and the other one goes rectifier, then this capacitor, and then we go and see. They have done it right. They twisted the cables. Oh, they didn't twist those two. Hey, complain. But at least they twisted those. They kept them quite nice together. So far, so good. But I also see some AC. Yep, the purple and the gray. That is some AC. And so AC goes here as well. Maybe it needs to detect the mains. And what is the red button doing here? This is the reset thing. So I took out all the screws from the rear panel. And look at this. The temperature sensor here is an 8590K temperature sensor. Really, really cute. It looks like they've built quite a few of them. The way that all the holes are made, and this was absolutely planned. Why is there this plate here in between? Why isn't it just mounted in the rear? That is a little bit different. Yeah, 8590 kH. Temperature sensor, here we can see it. That is really cute. Those are pretty expensive, so I'm going to score that one for my stock of cool sensors. Maybe I'm going to look a little bit more deeply into this PCB as well. All the different special mechanical parts, they got stamped in numbers, CQA and CQB and CQA. That is just amazing. They know what they're doing. Here, this is the bottom plate for the transformator unit. And again, the number. Ooh, a number under that little piece of metal as well. And this is just to hold this connector. Yep. And here is the PCB. I found a few really nice things. This is a Zener diode, and look, they're heating up the Zener diode with the regulated voltage. So that regulated voltage generates always the same power, and this power heats up the Zener, so it's more stable. So that's pretty cool. So this is the power supply. I found the AD converter. What they're using is they're using this counter. This can both generate signal, but it can also trigger for some timer events. So that means they made this into their own 3-channel dual slope converter. So look, those are the 3 analog signals. They go into the trigger inputs of that timer. So that is how they got their really nice AD converter. They got RAM, EEPROM, the RS232 line driver, a really weird integrated chip for that, and then the UART, and of course the main super brain. Oscillator. I found something a little bit more fun as well. This is the power supply, or the transformator, and also the rectified and the voltages from the transformator board. 2 of the lines, that is actually AC directly from the transformator. But look at that. This track. Something that is a little bit funny. Those 2 tracks, that's AC. That is not connected to anything else but a floating AC from the transformator. Here, they need to be swapped. For what reason? This is AC going only to the sensor board. Now, if we hold this board right next to the sensor board, this will indeed reveal a 1-to-1 connection diagram, right? So those 2, that will be those 2. The AC lines goes to a bridge rectifier. Surprise! That is a little bit funny. And of course a big capacitor and a little regulator. And now you have your a nice floating 24 volt your voltage that goes to a Zener diode and a constant current generator for the sensors. And here we got this really nice temperature sensor. And all the different chips here, they handle the temperature sensors. I really like the the way that they guardrail the signals. So that means they really care about those signals. And see the other one on the other side. For low crosstalk, it is not put under the other track. You can see it here. It's really clear. We're talking about a guardrail because it's all the way around the signal. See, all the way. Really, really nice. Definitely how you want to do this the right way. Look at the resistor. 100 mega and 1K 0.01%. They're really, really nice Wishay resistors. Look at that. I think they need to be saved for some funny future project. In fact, this board is not going to be trashed just because of those resistors. Because it's just better to keep them here, then I can find them. That is something you need to pay attention on when you trash some really old electronics you don't know what to use for, but look for special and exotic and expensive components. Someday you need to do voltage reference or measurement, something accurate. I always save small heat sinks like this, super convenient for all sorts of breadboarding or experiments. But just note one little cool thing they did. See the holes? They're not symmetric, and also because the hole here is not symmetric. The height of the transistor is not in the middle, and also the hole here is not in the middle. So the production guys, they can't mount this wrong. They can only do it right. This way you save instructions or manuals, how to assemble this and how to assemble that. Design it so it can only be assembled the right way. You save time and money and frustrations. It's just built into the design in any simple way. Just the power switch here is amazing. See, this one you can't get off, but if you stick this part through the front and lock it and then screw this back on, it will lock so it cannot go out. This is how you mount it. Isn't that just cute? And then there's a bulb in here. Look how well this is made. They're actually quite expensive. But since this one is hanging a little bit in the mechanics, I'm so sorry I can't keep this. Because I cannot use something that is not 100% perfect for anything. So you can save the whole light unit here. Change this if you want to. See the distance between the two micro switches. Oh, they actually work really, really nice. Super good feeling. Let's try and have a look. See? And this is made with rubber. I really like that method because it's always also give a really good hold of the wire. But I really like the feel of the micro switch. This is just super good quality.